So while Kavyan takes his time to join, are you okay? Not feeling hot, right? Okay, good. So today is Saturday, and what do we do on Saturday? We do tables. First thing we. What is that? Equivalent fractions. We'll come to that. First do tables and then we'll come to fractions. Okay? All right. So, since Tasvik is here after a break, let's see how much he remembers. So, in this group, we have kept our target to memorize tables till 12, which you had memorized almost before you went to India. So, some of the kids are ready till 10, some are till 12. It's okay, I mean, we have the entire year to memorize till 12. So, even if we go wrong, that's fine. Okay? And I heard that Tasvik's one more friend is joining from next week. You know, his name is Nihit. He joins Selvan Uncle's son. Okay, so all right. So let's check with Tasvik first. So table till 10. Okay, 9 8 there. 7 9 there. 9 8 there. 8 8 there. 6 9 there. 9 9 there. 10 9 there. 11 7 there. 12 5 there. 12 9 there. Good job. Very well done. So Tasvik was in India for 2.5 months, enjoying his summer break, but he seems to have stayed in touch with tables. So good job, Tasvik. Very well done. All right. Let's go to Salvi. Table till 10.
Yes.
9 8 there.
72.
7 9 there.
63.
9 9 there.
81.
8 7 there.
56.
8 9 there.
8 9 72.
6 8 there.
48.
4 9 there.
36.
Good job. Okay. So now let's go to Jaganya. Yeah? Okay. Table till 10, 12. 12. 12 7 there.
84.
8 9 there.
72.
6 8 there.
48.
12 3 there.
36.
7 7 there.
49.
8 8 there.
64.
6 9 there.
54.
Good job. Very well done. Okay. Now let's go to Aditi. Table till 10?
Yeah.
Okay. 7 7 there.
49.
4 9 there.
36.
8 7 there.
56.
7 8 there.
56.
8 9 there.
72.
9 9 there.
81.
8 7 there.
56.
10 9 there.
90.
Very happy. Very well done, beta. Okay. So everybody seems to be spending time with tables, and that is the building block for learning maths. If anybody says that I'm great with maths and I don't know tables, that is not right. That cannot be right. Okay. So if we know the tables, our base is strong, math becomes or keeps on getting easier and easier. Okay. All right. Now, what are we going to learn today? In the previous class, we learned fractions and we learned order of operation. Yes, Salni.
And we learn equal fraction.
Equivalent fraction. Okay, that is one of the things that we want to learn. What else? Let's see what you guys want to learn versus what I want to teach also. Let me see what are the things that we have in your syllabus which we have not done so far. Okay.
I kind of forgot.
Okay. So we'll learn about the equivalent fractions, and we'll also try to understand some concepts around area and perimeter. Only the concepts, okay? I don't want you guys to struggle with formulas and those fancy stuff right now. I want to make sure that I am forcefully pushing a lot of concepts around how you understand or relate area or perimeter thing in your day-to-day life. If you can relate it well, when you do more geometry, when you do more math, it will be more fun. Okay? So, let's first look at what is equivalent fraction, and then we will come to the basic concepts of area and perimeter. Okay? Okay? Alright. What happened to Kavyan? No response from Kavyan yet. Okay. If he's not joining, that's okay. He will not miss much. You can always watch the video offline. Alright. So, you all remember what is a fraction? When I divide something by something, is a fraction. I have 2 apples. I have to divide it equally among 5 kids. Everybody gets 2 by 5. I have $3. I have to distribute among 4 kids. Everybody gets 3 by $4. Okay, so this was my actual value which I divided among this many people. That's how you look at it. I had, let's say, $3. I have to distribute among 3 kids. This is what it becomes. $3 among 3 kids. Let's say my father had $500, and you guys would be surprised to know I had 4 more siblings. We were a family of 5 kids. I was the eldest and I have 4 younger brothers and sisters. So let's say my father had $500. If he had to distribute among 5 kids, what he had to do? 500 divided by 5, and that's what everybody gets. 500 by 5. Whatever is the value, that is what everybody gets. Be it me or any of my brother or my sister. Okay? So that is what is a fraction. Now, what do we mean by equivalent fraction? Meaning, when one fraction is same, the value of one fraction is same as other fraction. That is what is meant by equivalent fraction. These are called equivalent fraction. Now you will tell me why. Remember we were trying to do, yeah.
Because equivalent functions practically the numerator is half of the denominator.
That is one way of doing it, but okay. Jeremy is saying something. Yes, Beta. Go ahead. And Salini also saying something.
Sir, I just want to say that,
they're all equal because they're all half, like half of the full number.
Right. So here in this case, everything was translating into half. That's what Tasvik was saying, that's what Jaganya was saying, and Aditi and Shalini. Do you guys want to say something else?
They kind of doing the same thing.
Same thing, right? So when you look at any fraction, any two fraction, I will say these are equivalent fraction if the value of both the fraction is same. Now you will say it doesn't have to be same. 1 by 2 is not same as 4 by 8 or 2 by 4. I am saying the value of it is same, meaning when I say value, meaning I will first simplify it. 1 by 2, these are very small numbers, I cannot break it further. Can I break this? 4 by 8 I can write as 2 into 2 becomes 4, and here I can write 4 into 2 is 8. Now I can do tic-tac-toe. It becomes 2 by 4. Okay? So see, this and this look to be same. Now, 2 by 4, I can further break it. 2 I can write as 2 into 1. And 4 I can write as 2 into 2. And this 2 and this 2 I can do tic-tac-toe. What I am left with? 1 by 2. See, this 4 by 8 was at one point in time same as 2 by 4. And then, now after further simplification, this is equal to 1 by 2. So the value of two functions, if I have two functions, two fractions, upon simplification, if both have the same value, that is when they are called equivalent fraction. Now, look at this scenario. 3 by 9 and 9 by 27. Same thing here. What will I do? 3 by 9. This is a smaller one. Okay, let's look at the bigger one. 9 I can write as 3 into 3. And 27 I can write as 9 into 3. 9 3 is 27. Yeah? I can knock off 3 and 3. Tic-tac-toe. What is left with? 3 by 9. See, 9 by 27 became 3 by 9. Aren't these the same? So, equivalent fraction is nothing but when you have two fractions, upon simplification, if their value becomes same, that is when it is called equivalent fraction. Okay? Yaditi.
Is this the same thing we did on the previous class?
Kind of. So in the previous class we were learning factorization. Here also we are doing the same thing, factorization, but we are relating that in a different way. So equivalent fraction, nobody will say find out the equivalent fraction for something. It is always like, you'll be given two fractional values and you'll have to check whether they are equivalent or not. So whatever we have learned before, we are just applying the same thing here again. We are just simplifying it. Let's say tomorrow, no matter whether you are being asked to find equivalent fraction or do any calculation. Let's say somebody says 20 by 80. If you have something like this, these are big numbers. Our plan should always be to become like you guys, not like me. Meaning, you guys are small. Small things are easy to handle. Right? Let's say if for whatever reason, if somebody has to lift me and take me to the nearby doctor's place, do you think it will be easy for them to lift me? Do you think can anybody take me in the lap and take me to the doctor? That will not be fun. But if you guys feel tired and tell your parents that, okay, I'm tired, can you lift me? Your parents can happily lift you and say, okay, fine, you're my baby, come with me. But if I do the same thing to my parents, nobody will love that, okay? So that's what I'm saying. When they are smaller things, that's when it's easy to handle, easy to deal with. Here you are talking about 20 by 80. These are big numbers. You always try to simplify it, make it smaller. What you can do is 20 I can write as 10 into 2. 80 I can write as 10 into 8. This and this I can do tic-tac-toe. See, now this 20 by 8 become 2 by 8. I can make it even smaller. I can write 2 as 2 into 1 and 8 as 4 into 2. Yeah? I can do tic-tac-toe again. It became 1 by 4. See, 20 by 18, which are looking like a big number, how cute and easy this one looks now. Yeah? So, factorization is only a way to relate. Okay? Sorry. Factorization is a way to simplify the numbers into simpler numbers or easier numbers. And to your point, Aditi, we are not learning anything new. Salvi wanted to know how do we talk about equivalent fraction, meaning when I have two fractions, are they equivalent to each other? Are they equal to each other? Are they same? And this is the way to, when you simplify it and then you can compare. Let's look at these numbers, 3 by 9 and 9 by 27. Or let's say 4 by 16 and 16 by 64. Are these equivalent fraction? What I will do is I will simplify both of them. Let's make this cube, let's make this also cube. So 4 I can write as 4 into 1 and 16 I can write as 4 into 4. Okay, this is this one. Now this and this tic-tac-toe gone. This became 1 by 4. So this is not 4 by 16, this is 1 by 4, okay? This is a simpler number. Now let's look at this guy. 16 I can write as 4 into 4 and 64 I can write as 8 into 8. Again 4 into 4, 8 I can write as 4 into 2 into this 8 I can write as 4 into 2. Now I can do tic-tac-toe. Let me add 1 here. Okay? This 4 gone, this 4 gone. What it became? 1 by 2 into 2, 4. So now 4 by 16 simplest form is 1 by 4. 16 by 64 simplest form is 1 by 4. Both are same. So that is what is equivalent fraction actually. When you simplify two fractions and it gives you same value, that is when you say these are equivalent fractions. Okay? Aditi, is that clear?
Yes, sir.
Okay. Shalini, you were asking something.
So I have two questions. My man said like something. There's another technique to do it, and also the other question is, can you just like you see the tables in the denominator, the two tails? Why can't you just take them away like that?
No, why would you do that? So you do tic-tac-toe only when you have one in the numerator and one in the denominator. You will not do tic-tac-toe here and here. It's like killing your own team. When you do tic-tac-toe, right, what do? You have this. You are putting this, your opponent puts this. You are putting this, your opponent puts this. You are putting this. Right? So if your opponent puts a circle and you also put a circle, what do? You make your opponent win. Right? So the two teams. These are two teams, numerator and denominator are two different teams. You will tic-tac-toe, one numerator, one denominator. Not one here and one here, okay? Just be careful. Okay? Alright? Any questions so far? No? Yaliti?
Is tic-tac-toe really important for your work?
It's not work, it's play. I say always that, no, when I'm doing maths, I don't study, I play with maths. I want you guys to also play. Tic-tac-toe is nothing but, it's just a term that I use, right? If I have, let's say, if I have number like 25 by 120, let's say by 50, what will I do? I have to make it simple, right? I always say that math, if I have a math problem or any problem, any question, my job is to make it simple. What will I do? Convert the bigger numbers to smaller numbers, meaning factorize them. 25 is what? I can write as 5 into 5 and 50 I can write as 5 into 10. Now, tic-tac-toe is nothing but the playful side of me. I'm just playing with it, okay. I have 1 5 here, 1 5 here, knock it out. Tic-tac-toe. That's why I'm saying tic-tac-toe, okay. Maybe your teacher will not say tic-tac-toe, okay. I'm probably not a good teacher. That's why I'm playing with math, right? When the teacher is very serious, they will not say tic-tac-toe. It's okay, these two are done. Now if I have 5 by 10, so that becomes 5 by 10. Now, here also I see an opportunity. 5 under 5, 5 is 10. So, that means I can do tic-tac-toe again. 5 I can write as 5 into 1 and 10 I can write as 5 into 2. Again a tic-tac-toe. My number becomes smaller. So, tic-tac-toe is nothing but our approach for making a complex or bigger number small so that we can deal with it. Okay? And you can literally stop using tic-tac-toe if it makes your math calculation difficult. Okay? The day you feel that doing tic-tac-toe is a burden, don't do it. Because I introduced tic-tac-toe only for making it fun for you guys. That are you able to play? Are you able to enjoy? Are you able to take out the stress and do maths? Okay? So that is why I call it tic-tac-toe, because no, I mean doing math is difficult, but if I say okay, we'll do tic-tac-toe today, me and Tasvik will say okay fine, I'm starting here. I say okay fine, I'm doing it here. Then Tasvik say okay, I'll go here. I say no, I'm going here. We are playing here. The same thing, I'm playing here. Okay? Same way. So again, the purpose is to make it fun, make it easy. If you feel that it is not easy, don't do tic-tac-toe. It's perfectly fine. Okay? But you just have to have an alternate approach which works for you. Alright? Okay. So this was about the equivalent fraction, and again to your point, Shalini, there could be multiple ways of solving things. Okay? I am just giving you one approach. Tomorrow somebody gives you another approach, you can tell to us in the class. We will look at it, and if we find that more interesting, we'll use that. It's always up to us. We can choose which one we like, and we can follow the same approach. If you give me one problem, one mathematical problem, I might be able to solve it 4 different ways. But I will not use all 4 ways in the examination hall. In the examination hall, whichever I like, I'll use that. Okay? Alright? So, let's take a 1 minute break. I'll just go fill my water bottle and come back. Okay? And then we'll start talking about area and perimeter. We'll try understanding what is area, what is perimeter, how do we relate that with things in our surrounding, what exactly that means to us in our day-to-day life. Because see, does anybody teach us who are our parents? Does anybody teach us where do we live? Does anybody teach us that we go to bed after having dinner in the evening, right? No, because this is part of the routine that we see around us every day, that we practice every day, right? We don't study, we don't read books to find out the time for dinner, whom to call daddy, whom to call mommy kind of thing, right? We don't read that in the books. That is what we learn by practical example, by seeing things around us. So same way, we'll try learning, understanding what is area and perimeter by seeing things around us, relating to that, and then we'll find out how math helps us find it out. Give me 30 seconds, I'll fill this bottle and come back. Huh? Yes, sir.
Sorry, just did that
What is that?
You did that to level 3.
What is that?
Level 3 had area and perimeter.
Yes, not area. Level 3 has area and perimeter, but they talk about solid objects. They talk about rectangular, prism, cone, sphere. Want to learn that? They will talk about surface area, they'll talk about right cylinder. Don't rush. We'll go slow. So let me fill this bottle and come back. Huh? Oh, okay. Let me just tell them. We are just taking a 30-second break. If you guys want to use restroom or get some water, please do so. We'll start in 30 seconds, okay? Okay. Sorry, I took a little longer. Are we ready? Shall we start? Shalini, Aditi, everybody ready? Okay. Now, this is my, let's say, my piece of paper, okay? Okay. I want to draw a triangle on this piece of paper. Can I do that? I want to draw this bigger triangle on this piece of paper. Or I want to do more magic. I want to draw this bigger triangle on this bigger piece of paper. Can I do it? No? Okay, Tasvik says I cannot do it. Anybody? No, we cannot do it. Can you tell me why?
Because the paper sheet is smaller than the triangle.
Okay, so the paper sheet is smaller than this triangle. Okay. Any other answer why we can't do it? I mean, what Tasvik said that is perfectly fine. I'm just trying to read everybody's mind. Why you think that I cannot draw this triangle on this piece of paper, and if somebody is, let's say, one of the uncle in the neighborhood says that, okay, Jaganya, draw this triangle on this piece of paper, you will say, no, I cannot, but you'll have to tell why. Yes, Alni, tell me why.
Because the squares are quadrilateral, like the shape, and also the area. Sorry, the perimeter is there.
Don't mix. So, see, you have heard some terms which are mathematically powerful, but I'm not trying to go there yet. I'm trying to look at it like a child, like somebody who doesn't know math, who can only observe things in the surrounding and make a response. So yeah, Jaganya, I mean, see again, I know I'm trying to, I'm kind of forcing you guys, but I'm trying to see how your mind thinks, how you relate in a normal scenario. Aditi, any thoughts? I'm saying, draw this triangle on this piece of paper, and you guys saying that no, it cannot be done. Now I want to tell you, I want to know from you why. Just tell me why. I mean, I'm a very stupid guy. I don't understand things. If you have to explain me, yeah.
I think like the triangle area is bigger than the rectangle area.
Yeah, that's a very polished answer. Probably a little too much for somebody who is as dumb as me. Now again, I'm saying something. There's a meaning to it. Okay, I'm saying that don't look at things in a mathematical way always, because math is nothing but a tool or a technique that we learn. But life is much bigger than math. Okay? Yeah, you're saying something?
Maybe it's because like a triangle is bigger than the rectangle.
That is one way of saying it. Triangle is bigger than this. Like Tasvik also said that the area of this is more than this, right? I mean, you guys were reading that way. So, like a normal human brain, right? Who doesn't want to talk about math? Like you guys said, this is smaller, this is much bigger. You cannot draw a big thing on a small piece of paper. This is a much bigger thing. If I have to draw my house on this smaller piece of paper, I cannot draw it. I can probably create a small sketch, but I cannot draw the whole house. Because the space needed by this object, the space that this guy needs, is much more than what this guy has. It's like you are asking somebody to give you $20 who has only $2 in his wallet right now. this guy has only $2. You're saying that put this $20 thing, or use $2 to buy this $20 thing. So, simple way, if I look at this, now forget about this being a math class. Okay? Think like we are friends going to play. Okay? As soon as you draw on this one, your first response will be, are you mad or what? That's what you'll say, right? To a friend. Don't you see that this is much bigger than this? That's what you'll say, right? That's how our brain processes it. Brain doesn't know math or not. Alright? So, same way, here also, we'll say, okay, fine, this space is much lesser than what this guy needs. That's why I cannot draw it. That's a practical response. In mathematical terms, how you say, oh, the area of this piece of paper is way too small to plot something like this. That is when the math concept will come. Okay, so Aditya, whatever I'm saying is, my first response when looking at these two shapes is, I cannot draw this bigger triangle on this smaller paper. Right? That will be our first response. Right? Now, in math, how do we relate? We say the space that this guy needs is the area. The space that this guy needs is the area. Okay? Now, there is one more thing here. Do you see this whiteboard here? This is the total area I have for teaching you guys. If I want more area, I'll end up scribbling on the wall. Yeah? Correct? So this is my total area that I have. So area of any shape, if I'm talking about triangle, if I'm talking about quadrilateral or rectangle, I'm talking about a square, I'm talking about circle, I'm talking about trapezium, I'm talking about parallelogram. These are different shapes, okay? And every shape, as you can see, is needing some space on the board. Let's say if I draw a lot of things here, and I have to draw two more big circles. What I will say, I don't think I have any area or space left on the board to draw other shapes. So every shape takes certain space on the surface where you are drawing it. That is nothing but the area. Okay? Yeah? Now you look at my hand. All that you see here is area. Let's say if I want to do some nail paint, or nail paint I will not do here, right? I'll do it here. Okay, fine. If I want to do some palm paint, if I want to make Minnie Mouse, Mickey Mouse, or some He-Man, Superman, whatnot, right? This is the total area I have. Can I draw Spider-Man here, Batman here, He-Man here? I have limited area here. So anything that you see on the surface, that is your area. Let's say if I'm standing here in this classroom, I have enough area where I can put my feet. If you say, stand on the top of this pen, can I stand here? No. Because the area that this strip has is much less than the area that my feet, both my foot needs. Right? So that is how you relate to area. You buy a big 150-inch television and try putting it on a small wall. Can you do it? No, because the screen needs certain area, and you can only put that screen on a wall which has bigger than that area, right? So that is how I have put this board here, because the wall had much more area and this has consumed one part of it. Yeah. If I would have tried putting this board on the top of this one, I did not have enough area, right? It would have not gone there, right? So that is the way you relate with area. If I talk about area of this circle, this is this much area. If I talk about this circle, baby circle, this needs less area. This is needing lesser area. If I have this much space, what do you see? If I have to draw this baby circle, I can probably draw 10 of them. If I have to draw this big circle, I can draw only 3. Yeah? So basically, area is nothing but the space taken by any object on the surface where you are keeping it. Okay? Is that clear? Now you can look around you. Everything that you see around you is needing some space. Can you put an elephant in your bedroom? You cannot, because it doesn't have enough area. I mean, obviously we'll talk about volume when we go next. But for now, the amount of space that elephant needs on a surface is much more than the size of our rooms. So that's why we cannot put an elephant in the room. We need a much bigger space. So that's how you look at the area. Now, this is a small area, this is very small, this is bigger area, this is bigger area. Now, who all has been to India recently? Except Tasvik. Anybody went to India recently? Yaditi?
I went on last year.
Last year? Okay. Now, did you go? Have you guys gone to your your farming land in the village? Have you seen how it looks like? Let's say you go to a farm. It will be like, this is a farm. Maybe this is your land. Somebody has this land. Somebody has this part of the land, right? If you look at it carefully, these look like the geometrical shape that we're talking about. See, this is a rectangle. This is also a rectangle. Maybe this is a square. So people say, I have a big land, meaning the area of their land is bigger. If you look between this one, and this one is the biggest land, right? And this one has biggest area. So when people brag about having a lot of property, they say, I have a big land, meaning that the area of their land is a lot more. Okay? So that's how you look at this one. So we'll talk about those things one by one, but for now, area of any shape is the space taken by on the surface. Okay? So here, on the earth's surface, this is the land. Okay? If let's say if I'm a very poor guy, I have this smaller land. Somebody who is very rich has this bigger land. Yeah? So that's how you relate area with what you see in your surroundings. Okay? Now let's look at other things. That is called perimeter. And then we will go to different shapes. We'll try learning about them and the properties of those shapes. Okay? Now, if I'm talking about this shape, this is the amount of space taken by this guy. That is the area. Now, do you know what is perimeter? Yep. Yes, Salini.
Something around the shape.
Around the shape or the border of the shape. Meaning, imagine this is your farm and you have to barricade it. Cover from here to here, here to here, here to here, here to here. The entire boundary of the shape is called perimeter. So if you look at any shape, if you are looking at this shape, what is the area? This is the total space taken by this guy. What is the perimeter? From here to here, here to here. Basically you have to traverse along the boundary of the shape, that gives you the perimeter. So perimeter of any shape is the total length of the boundary. If you have to put a wall, this is the length of the wall. Okay? If you have to cover your shape with a wall, this is the length of the wall, is the perimeter. So if I am talking about the perimeter of the circle, it's from here till here. The length of the total wall is your perimeter. Is that okay so far? Are you ready with me? Is everything clear so far? Okay. Just 1 second. Is somebody clear? Okay. Huh? Yeah, that's what it is. You missed. You just put it down. All right. So this is the area and this is the perimeter that we talked about. Yeah. Just give me 2 minutes, okay? Just 2 minutes. What's your name? Come over. Now see, you are early by 10 minutes. This is a class for junior kids going on. We'll start level 1, 3rd to 5th grade. Yeah. So let him sit down, settle down.
Yeah.
And he'll be done by 6, so we can talk.
Okay, I'm not sure if I'm stop, right?
Okay. That's okay. That's fine. So take a chair. Sit down. I'll teach you. And if you want to see how it is, it's okay. You can be a.
No, over there you said you will.
It will be there in the video. Anyway.
Yeah.
Okay. All right. Okay. So we talked about area. We talked about perimeter. Any questions so far? No. Now let's play with some shapes. So Tanu, I mean, this is not for you, but if there is something that you find interesting, if you want to participate, let me know. Okay. All right. Now let's look at different types of shapes that we want to learn about, or that we will come across as we see different things. So let me ask you some simple questions. Have you guys seen these things? This is something, this is something, this is something. Do you guys know what is that called? What are these called? Yeah.
Lines.
Yeah, Aditi?
Lines.
Lines. That's a very generic term. Okay. Anything else? Jaganya, you want to say something?
I just wanted to name what are those lines called.
One of them is called line. Okay. Tasnik, do you remember? What are these called? Okay, yeah, Jaganya.
Like I heard the last one that it's called ring.
This is called ray. So this is called line. When you have arrow on both the sides. When you don't have arrow, these are called line. Line segment. This is called line segment, piece of a line. And this is called a ray. The difference here is a line, when you say a line, it has no length, it has no fixed length, it is just showing you the direction. So it is telling you the direction. You cannot say, I have a line, look a length of 10 centimeters. This will be a wrong statement. Because your line doesn't have a fixed length. It just gives you a direction. It tells you it is going this direction, and it could go as far as you can imagine. Okay? A line segment is a piece of a line where you have a starting point, you have an ending point, and you have a fixed length. Here if you say this is 8 centimeter or 10 centimeter, this is correct. Okay? So, in case of a line, there is no starting ending point, it is just a direction, it cannot have a fixed length. In case of a line segment, it has a starting point, ending point, and it has a fixed length. In case of a ray, it has a starting point and a direction. Now, if you look at this, if you look at this phone, right, what's happening? If you imagine this light is starting from here going in a certain direction, Depending on how powerful this torch was, it will go as far as you can think of. Yeah? Now, that is exactly what is happening here. It has a starting point and it has a direction. If I turn my phone this way, this is the starting point, this is the direction. If I turn this way, this is the starting point, this is the direction. That is exactly what is a ray. So you will say ray, you will see ray coming into picture in a scenario like this where you have a light starting from a point and going in a direction. Again, rays will only have a starting point as a fixed point and a direction known. You cannot say a ray of length 20 centimeters. That will not be correct. Okay? Here, in case of a line segment, you have a starting point, ending point and a fixed length. In case of a line, you just have direction. Any questions here so far? No? No questions? Tasvik, no questions? Tanu? Any no questions? Okay, I know. Tanu must be laughing at me saying, oh, this is for younger kids. I have seen it but before. Okay. Alright. Now let's look at, so far we looked at only one line. We have 5 more minutes. We'll learn 2 more things and then we'll call it a day. Now, this is a line. Okay? Fine. One line is okay. What if I have another line messing with this guy? Let's say this was my line A to B and this is my line in the direction C and D. This is meeting somewhere here. Let's say it's meeting at point O. Here they are intersecting each other. That's what we call it. The lines are intersecting each other. Okay? And this is the point of intersection. And here you will see they are at a certain inclination. That is called angle. This is called angle. Imagine the 2 lines meeting like this. See, they seem to be far apart, unlike this guy. Imagine 2 lines meeting like this. It's further apart. Okay? This is called angle. So, depending on how close or far these lines are when they are meeting each other, this is called angle. Okay? So, angle could be small or angle could be big. Yeah? So these are 2 lines meeting here, small angles. Angles are becoming bigger. I cannot fold it beyond this. It can become bigger, but I am not going to fold it beyond this. So, this is the inclination between the 2 lines when they meet each other is called angle. Okay? We'll learn more about it. We have a long way to go. This is one situation when they are making angles. Angles are measured in terms of degree. Okay? So, if you see 2 lines meeting each other, perpendicular to each other, this is called 90 degree or right angle. If the lines are closer to each other, meaning it is less than 90 degree, it's called acute angle. Something which is small and acute. Acute angle. Okay? This is called right angle. Right angle. And if the lines are far apart, meaning this angle is greater than 90 degree, this is called obtuse angle. Okay? So, we learned about the 3 varieties of line, where we learned about line segment and rays. Then we looked at how when the lines meet, they meet each other at certain inclination, which is called angles, which could be big or small. Smaller angles are called acute angle, bigger angles are called obtuse angle, and the angle which is exactly 90 degree, that is called right angle. So, hello, is this Darka?
Hello.
Hello, beta. So you have joined 5 minutes early. So let just be in the class. Allow me to finish this class for the kids from the previous class, and then we'll resume. I mean, so you can either stay in the class or you can join back after 3-4 minutes. That's all. Either way is okay. Okay.
I'll just stay.
You just stay. Okay. All right. Arav, find a chair for yourself. Take this one, this one. Or Tadul, if you want to take this chair. All right. So we learned about the line segment and rays. Then we looked at the angles, different types of angles. That is where we'll probably stop. We will learn about the parallel lines, and then we'll learn about the polygons in the subsequent classes. But in summary, so we'll do Bharatanatyam after we are done with this class. Salini is practicing Bharatanatyam right now. But so coming back to this one, we just a quick recap of what all we learned. We learned the equivalent fractions. Then we learned about the basic geometry, where we talked about the 3 types of line segments and rays. Then we talked about when the lines intersect, what is the inclination among them, that is called angle, and then we talked about the 3 different types of angles. So that is where we will stop. Any questions before we